क्या उसको कॉम्बैट ट्रेनिंग ले रहा था क्या? हाँ मैं सिखाता हूँ किस तरह को।
टेबल खोलने पर थोड़ा सा
नहीं उसमें टूटता है।
क्या टूटता है?
तेरे याद है ना?
सर उनको क्लास के
चलो अब हम क्या करेंगे यहाँ पे? कहाँ गए थे पेट भरने?
भूख लगी थी सर।
सवेरे क्या कर रहे थे? कौन कौन कितने कितने बजे उठा आज पहले बताओ? ये तो रात भर जगी थी क्योंकि सवेरे टाइम पे आ रहा था। रात भर जगी थी ना? कितने बजे सोती है? भूत सारे के सारे भूत है यहाँ। कौन सबसे जल्दी कौन सोता है यहाँ पे? What time you all sleep?
1:30
1:30 क्या करते हो? 3 o'clock घर के काम।
2:30
सबसे जल्दी कौन सोता है? 1:30 हो। ये 1 o'clock से ये सबसे जल्दी
12:30
क्या करते रहते हो? हाँ Okay guys, change your habits, हाँ मतलब sleep early, get up early. 3:34 you can get up. लेकिन जल्दी सो जाओ. Otherwise you will spoil your body metabolism. पता? ये झूठ बोल रहे हैं, इसके बातों में मुझे बिल्कुल विश्वास नहीं। ओके चलो अब हम यहाँ पे देखते हैं। हमने क्या देखा? इमेज कहाँ बन रही है? इमेज कहाँ पे बनती है? जहाँ पे रिफ्लेक्टेड रेस या तो इंटरसेक्ट करते हैं या रिफ्लेक्टेड रेस जहाँ से अपीयर करते हैं, कहाँ से आ रहे हैं। Either they will converge or they will diverge. ठीक है? तो जहाँ से डाइवर्ज हो रही है तो इमेज वहाँ बनेगी, वहाँ पे वर्चुअल बन जाएगी, और जहाँ पे कन्वर्ज हो रही है वहाँ पे क्या बनेगी? रियल इमेज। यही था ना? रियल और वर्चुअल इमेज का डिफरेंस देख लो। तो हमने फर्स्ट टाइम देख रहे हैं रियल इमेज हमारी यहाँ पे फॉर्म होगी, लेकिन अब ये इमेज कैसी बन रही है? पॉइंट साइज। दोनों रेस कहाँ मिल रहे हैं? पॉइंट पे या इमेज। ठीक है? तो अब अगर ये हमारा एंगल थीटा है, ये दोनों पैरेलल लाइन है, तो ये भी मेरा एंगल क्या बनेगा? थीटा बनेगा। ठीक है? ये क्या बन गया मेरा? आइसोसेलेस ट्रायंगल। करेक्ट? तो ट्रायंगल CMF is isosceles triangle. बराबर? ये दोनों एंगल सेम ही होंगे, है कि नहीं? Why these angles will be same? Because this is angle of reflection, so incidence equal to reflection. दोनों थीटा हो गया। और ये क्या है? Alternate angle. This and this ray are parallel. This is theta. This also will be theta. Because perpendicular. Normal is acting as transversal. ठीक है? अच्छा। So ये क्या होगा? CF is equal to MF हो जाएगा। करेक्ट? CF is equal to FM. अब हम इसमें एक जुगाड़ करने वाले हैं। जुगाड़ क्या है? You are okay, right? CF is equal to FM. If this ray is traveling very close to the principal axis, तो क्या होगा? देखो ये वाला जो लाइन है, if M is very close to P, तो ये जो लाइन है M dash will become P only. अगर ये हम M को नीचे लेके आएंगे, है ना? M को अगर नीचे लेके आएंगे तो FM will become FP. समझ आया? समझ आया कि नहीं? क्योंकि ये पैरेलल रे तो हमने ऐसे ही दूर दिखाई है, लेकिन एक्चुअली में क्या हो रहा है? रेस तो हर जगह जा रही है, और ये वाला रिलेशन सबके लिए एप्लीकेबल है। ठीक है? सो इफ the incident rate is very close to principal excess, then will be equal to F, will be equal to FE. होगा कि नहीं? तो अब इसको हम क्या लिख सकते हैं? इक्वल टू FP हो जाएगा. CF will be equal to FP. Correct? तो अब दोनों तरफ हम FP कर देते हैं. Therefore, CF plus FP is equal to FP plus FP. ये कर सकते हैं? Add FP both sides. ये क्या हो जाएगा? CF plus SP becomes CP. But what is CP? CP is R. FP is F. Correct? CP is radius of curvature. ये तो radius of curvature है. ये वाला distance. ये वाला distance क्या है? Focal. ठीक है? तो R is equal to 2F. इसका मतलब क्या हो गया? ये तुम्हारा डेरिवेशन हो गया. रिलेशन बिटवीन रेडियस ऑफ कर्वेचर एंड फोकल लेंथ. फोकल लेंथ हमेशा रेडियस ऑफ कर्वेचर का आधा होता है. ठीक है? लिख लो इसको. So image formation by a concave mirror and relation between F and R. Done? Is there any step that is not understood? Let me know. ये क्या कर रही है? Have you written?
Everything. Yeah.
मैं सो लेती अच्छे रीड एंड क्या हो गया था बेटी
या
ठीक है मुझे बताओ लिखने के बाद सब
कैसे ठीक है
ओए क्या चल रहा है
हार्वेस्ट
डन
यस
चलो now we'll do image formation by concave mirror we can do the same proof by using a convex mirror also ठीक है खाली रे डायग्राम चेंज होगा देखो instead of concave mirror the same relation will hold for convex mirror also same relation can be obtained for convex mirror देखो कैसे यहाँ पे प्रिंसिपल एक्सिस यहाँ से आया तो इसका सी किधर होगा राइट साइड और एफ किधर होगा यहाँ बीच में तो ये होगा P। ठीक है, यहां से जो रे जा रही है E और F होते हुए C पे जाएगी, रे पहुंचेगी क्या? नहीं पहुंचेगी, तो रिफ्लेक्ट कहां से होगी? यहीं से होगी। प्रिंसिपल एक्सिस वाली जो रे है वो यहीं से रिफ्लेक्ट होगी। अब पैरेलल इंसिडेंट रे यहां आ रही है, ये आगे जाएगी वजह से नहीं जाएगी, रिफ्लेक्ट कहां होगा? किस तरफ? तो इसको नॉर्मल बनाओ पहले, नॉर्मल कहां बनेगा इसके लिए? इसका नॉर्मल तो कहां से रिफ्लेक्ट होगी? ये ऐसे, तो ये हो गया इसका एंगल थीटा, एंगल ऑफ इंसिडेंस। एंगल ऑफ रिफ्लेक्शन क्या बनेगा? ये कहां से रिफ्लेक्ट होगा? ये फोकस से, तो ये भी एंगल क्या बनेगा? थीटा बनेगा। ठीक है, तो ये नॉर्मल और ये इसको तुम मिलाओगे तो क्या बन जाएगा? थीटा। ठीक है, और ये पैरेलल है, ये दोनों रेस पैरेलल है, ये वाली और ये वाली, ये भी एंगल क्या बनेगा? थीटा। ठीक है, तो ये फिर से तुम्हारा सेम एंगल, और ये पॉइंट को तुम M मान लो, इसको ये पॉइंट बनेगा M डैश। डिट्टो स्टेप्स रिलेट टू सेम। अब इसका जो R है वो किस तरफ पड़ेगा, और इसका जो F है समझा? तो रे डायग्राम्स करेक्ट होना चाहिए। क्वेश्चन में कभी कभी ट्विस्ट कर देता है, मान लो तुमने प्रैक्टिस खाली किस पे किया है? कॉनकेव मिरर पे, और अब तुमको क्वेश्चन आ गया कि डिराइव दैट रिलेशन फॉर कॉन्वेक्स मिरर, सेम ही स्टेप है, सेम टू सेम, एक्चुअल लेबलिंग इज आल्सो सेम। अंडरस्टूड? ठीक है, नाउ विल स्टार्ट। नाउ यू माइट बी सीइंग, so where is the image forming in this case? At ये डाइवर्जिंग रे है, कौन सी? एक ये रे थी, ये डाइवर्ज हो गई, रिफ्लेक्टेड, और ये वाली ये आ रही है, तो ये दोनों को जब पीछे लेके जाओगे तो यहाँ बन रही इमेज, यहाँ पे बन रही। इसमें इमेज कहाँ बन रही थी? यहाँ पे। What is the nature of image in both cases? नेचर रियल है कि वर्चुअल है?
इसमें रियल है,
यहाँ पे रियल है, बिकॉज एक्चुअली द रिफ्लेक्टेड रेज आर मीटिंग, इंटरसेक्टिंग,
रियल एंड इन्वर्टेड,
और यहाँ पे वर्चुअल है, दिस रेज आर appearing to be diverging from it। फर्क समझ में आ गया अभी? ये है तुम्हारा वर्चुअल इमेज, ये तुम्हारा रियल इमेज। तो रियल इमेज कैसी होती है? इन्वर्टेड। यहाँ पे भी वर्ड रियल आया, वहां पे इन्वर्टेड। यू नीड नॉट राइट लाइक दिस इन द डायग्राम, जस्ट लेटर से लेवल करना है डायग्राम को। सो रे डायग्राम में हमेशा रिफ्लेक्ट, इंसिडेंट और रिफ्लेक्टेड दोनों डायरेक्शन होने चाहिए क्लियरली। फॉर एवरी रे द इंसिडेंट डायरेक्शन एंड रिफ्लेक्टेड डायरेक्शन शुड बी मेड, एंड प्रॉपर लेबलिंग ऑफ पोल, फोकस एंड center of curvature should be there, otherwise you will not get marks. Wherever necessary, draw normal. Normal is not compulsory always, depending upon the question you can draw normal. ठीक है, so what is the learning here? Whenever the ray is parallel, either it is diverging away from focus or it will converge at focus. Parallel incident ray either will pass through focus or it will go away from focus, depending upon the mirror you have chosen. ठीक है? ठीक है? Now, let's discuss rays to be considered image formation. So how many rays to be considered for image formation? Minimum 2. But how many rays you can consider totally? In total 4. There are 4 possible rays. First, ray incident parallel. So ray incident parallel. In this case, ray is incident parallel. Okay? क्या होता है उसको? Passes through focus after reflection. ठीक है? Ray incident parallel to principal axis passes through focus after reflection. This is point number 1. We have seen that. Opposite of this is also true. What is opposite? Ray which is incident. Just change the direction. Ray incident along focus will become parallel to principal axis after reflection. Just change the direction. If ray is incident along focus, will become parallel to principal axis after reflection. Opposite. Towards focus or along focus. So wherever you are writing principal, okay, you have to write AL. I make this mistake often. Principal axis after reflection. So you have to be careful. This direction you have to show on the reflecting side only. क्योंकि यहाँ पे आगे नहीं जाएगा. यहाँ पे आगे नहीं जाएगा. Okay. So these are the 2 rays. Third ray, what you can take? See, ray incident along center of curvature. Ray incident along center of curvature will retrace the path. क्योंकि नॉर्मल पे गई है तो नॉर्मल से ही वापस आई. ठीक है? Look here. Ray incident along center of curvature will retrace the path. Have you understood the third one? Have you understood the third one? Ray incident along center of curvature will retrace the path. Why? Because center of curvature is normal. देखो, if the ray is incident along C, वापस जाएगा C से. यहाँ पे भी क्या हो रहा है? Ray is going towards C, तो C तक तो पहुँचेगा नहीं, फिर वापस चला जाएगा. ठीक है? फोर्थ क्या लोगे? Ray incident along P ray incident along pole क्या होगा?
सेम होगा.
सेम एंगल पे ऑन द अदर साइड ऑफ द प्रिंसिपल एक्सिस, क्योंकि प्रिंसिपल एक्सिस तो नॉर्मल है ना. रे इंसिडेंट along P will be reflected by same angle of incidence, by same angle on the other side of principal axis. What I mean is this. Let's say you have a convex mirror. This is P. ऐसे हो गया. ठीक है ना. अगर तुम्हारे पास कॉन्वेक्स मिरर है तो क्या होगा? ये भी यहाँ से यहाँ. समझ आ गया? रे इंसिडेंट along P will be reflected on the other side, because principal axis is also the norm. So all first three rays are shown in the first two diagrams, right? The last one I have shown separately. So these are the four rays to be considered during image formation. When the lecture will end? 10:45. Still a lot of time. Any two of the above four rays can be considered. For now store these four rays in your head. Henceforth, I will only be drawing diagrams. And you should know what will happen if the ray is incident parallel to the principal axis, it will pass through focus. If the ray is incident towards focus, it will become parallel to the principal axis. So these two are opposite cases. Just the direction will intersect. Incident here, reflected parallel. If it is incident parallel, reflected away from focus. Or in this case, it will be incident parallel, it will be after reflection pass through focus. Okay? So depending upon the mirror selected, okay, and the ray chosen, we will have the reflected ray. Then third case, if the ray is incident along center of curvature. So here this ray is incident along center of curvature, so it will retrace. Same here. For center of curvature, there is one diagram here also. If ray is incident along center of curvature, it will go back. Okay. And over here, if the ray is incident along center of curvature, it will be reflected back. Okay. Now you should be able to understand. These four things are required. Okay. So let's start with the formation of images. Are you ready? So we are done with all the foundations needed. So draw the ray diagram for image formation by concave mirror and convex mirror. Can I erase this side? The image formation by concave mirrors. First is case is object at infinity. Yes. So when the object is at infinity, right? Like infinity. तो उस केस में सबसे पहले क्या करना है? We draw the mirror. Then the principal axis. This is the first step. So mark this as gold and then silver. Then you have to mark 2 points, C and F. The trick is do not label it right in the beginning. C और F अभी मत लिखो. पहले पूरा race complete करो. Last में labeling करना है. So now, when the object is at infinity, only parallel rays will be incident. Because whenever you look at any far object, say at sun or star, right? When you look at any far object, how is your eyes? Like if I look at this CCTV, now all the lights are coming parallel to me. It is like one point. Stars or suns are one point. So all the rays will be parallel. So parallel ray will pass through focus. So now I need not draw the normal. I now know if the ray is incident parallel, after reflection it is going to pass through focus. Now write the alphabets C and F. Okay. So whenever object is at infinity, all incident rays will be parallel to principal axis. Okay. So now we have to write the properties of image form. So where is image position? You have to mention 3 things: image position, nature of image, and size, image size. 3 things you have to mention for every case. So what is image position?
Focus.
At focus. So you will just write at F. Now we have defined once and for all. F means focus. So focus is a point. F is a point. Center of curvature is a point. So we now know what is C, what is F. Nature of image?
Real and inverted.
Real and inverted. Yes. So image size is highly diminished. You can write highly diminished or you can also write point sized or point sized. These three things you have to write for every object case. Now, one is object at infinity. Next is far away object. So. Actually, the second case given in your book is for far away object. Like this CCTV is far away object. It's not infinity. Infinity is sun. या फिर across the road any tree, है ना? तो tree भले बड़ा है, but अगर far away है, तो I don't watch the tree like this. The way I am watching the CCTV like this. Tree may be far away like a hill. We still, keep our eyes straight, isn't it? है ना? Even when we are watching sunset, तो हम कैसे करते हैं? Unless the object is vertical, even if it is far away, we keep the eye level parallel. That's how this parallel. So when object is infinite distance away, very far away, then it is like this, parallel to the principal axis. But when we see the far away objects, we do get parallel rays, okay? But they are not parallel to principal axis. They are parallel to each other, but they are not parallel to principal axis. For example, let us say the object is far away. The incident rays are parallel. We require at least two rays. The incident rays are parallel, like in this case, they are parallel to each other, but they are not parallel to principal axis. In this case, the image is formed at focal plane. So now what is the normal here? C. Okay, this is normal. And this is the normal here. So where will be the angle of reflection? Equal angle here. So it meets somewhere here, let us see. Equal angle. This will be here. Okay. This is our. So what is happening? Incident ray and the reflected ray. So where is it meeting? It is meeting in the focal plane now. So this is called focal plane. Focal plane is the perpendicular plane passing through focus. So the distance of image is still this is V. V is the image distance. Okay. So the image is still at F. So all the properties same. Exactly same. 1 and 2 cases are same. Only difference is the image is point sized, but in the focal plane, not at focus. Whereas focal plane passes through the focus.
Diminished.
It is no highly diminished. Why highly diminished? Because we don't know. It is far away object. The object size is very big. Look here. This object is, you don't know where it is. So if you compare the object size with the principal axis, it is still very big. As compared to that, this is highly diminished. You get it? So exactly same. Write down all these three features. Same. So it is at F, real and inverted. Yes. Only in ICSE these two cases are given separately. In everywhere else in CBSE they don't call this as a separate case. These are one. Okay, these are exactly same thing. Right? Third. Now see, what are the places where you can keep the object? One is very far away, which is infinity. or far away. Next is the object can be beyond C, then at C, then between C and F, at F, between F and P. Okay, so there are 6, 7 object positions. Actually 6, because this and this if you count as 1, then there are 1, then 2, 3, 4, 5, 6. Only 6 object positions. Understood? These are the 3 reference points. Okay, so 2 objects on the points, rest either beyond or between. Okay, so total 6 cases. The third case will be object beyond C. Why are we saying beyond C although we are coming closer? Because distances are measured from P always. So now it is P to C and beyond C like this. Okay, so object beyond C. So beyond C में पहले तो ये करना है and do the silver coating, then mark 2 points C and F. So when you are doing it with the help of scale, let's say you have taken this as 6 centimeter, then F will be at 3 centimeter from P. Make P your reference. So अगर P से C 6 centimeter है, so P से F कितना होगा 3. ठीक है? Because you know that F is midpoint of CP, right? Now when the object is close to the mirror, this is our object. We call this AB. Now how to draw the image in this case? क्या नाम है इसका? EN, CN. EN. विजय इसको लेके जाओ बाहर. डेढ़ बजे से ना कितने बजे 3:30 पानी डाल दूंगा अभी इसमें. ठीक है? Look here. So what is the object position in this case? Object is beyond C. We are not writing C and F for a reason, because when you draw the reflected ray, sometimes it crosses the written alphabet. So first we'll draw the reflected ray, only then we will do the labeling in the end. So labeling में क्या पहले तो हमारा object हो गया AB. So we will take both the rays from top of the object. ठीक है? So one parallel. So this will pass through focus. We know that it will pass through focus. Other we can take either through C. So if we take it through C, it will go back. Or you can take it through F also. Then it will be parallel. So the diagram may be different in the book. If you take it through C, तो mirror थोड़ा बड़ा लेना पड़ेगा. ये अगर इंसिडेंट रहे तो पैरेलल यहाँ पे. So where is the image forming? Yeah. So this becomes A dash and B dash. So you can see that image is slightly smaller than object. Okay, this is freehand drawn diagram. That's why this image will be smaller than this. Is that clear? It is going through C, therefore this is C, right? Center of curve. So image कहाँ पे बन रहा है? Image at C.
Between C and
Between C and F. Yes. Image between C and F. Whenever the object is beyond C, image is between C and F. और क्या हो रहा है? Real and inverted. Now you can see object is like this and image is real as well as inverted. So we have taken 2 rays from the top of the object. Likewise, you can take 2 rays from everywhere. So you will see the image. So this thing will be reconstructed fully. Only for indication's sake, we are taking, you're choosing the top of the object. But rays are going from every point on the object. Okay, so you will have a filled diagram. So you won't be able to figure out कैसे बनता है. इसलिए खाली A का बना दो. Principal axis तक उसको क्या करना है? Draw it till the principal axis. And what is the nature in this case? Diminished.
Size.
Diminished. Size is diminished. ठीक है?
Smaller to the
Yes. So that's why it is diminished. Diminished means small. Okay. Is it highly diminished? No, because now the image size is comparable. Slightly small. That's why it is diminished. What is the next object position?
between center of curvature.
No, at C. At C. Okay. So object at C. So when the object is at C, you will realize that the image is also at C. Okay, so everybody look here. So first ray parallel. So reflected ray through here. This is reflected through here. And then what about the next one? What ray would be convenient? Take it through here. And after reflection, this would become parallel. This. So wherever the reflected ray is meeting, exactly below C. Okay, so this is A dash, B dash. This point is now the image size is equal.
Yeah.
So now you are able to decode the pattern. So image
At C.
At C.
Real and inverted and same size.
yes. Okay. So now label. So C we have made, now F. So write it in the head. Otherwise, the reflected ray might cut it. So you'll have to erase and have for doubles. You know? So do the labeling part in the end. So labeling consists of writing all the points and direction of incident and reflected. Very important. Otherwise, you will not get marks. Very strict. Okay. So current direction in electrical circuit, okay, as well as the direction of incident and reflected ray, plus the labeling, proper labeling. Very important. What is the next object position?
Between C and F.
Yes. So what is the pattern you have observed so far? When the object is at infinity, the image was at F and it was highly diminished. When the object is coming closer, the image is shifting away from focus. Object coming close, image is going away, and the size is increasing.
Yeah.
First, it was point size, now it is becoming diminished, means the image size has increased. Now look here, it has gone further away, and the image size has further increased. So it's like this. Okay, object coming closer, image going away with increasing size. It's very simple to remember. Next. Yes. And you have to remember for various object position where the image is obtained. This will help you solve your numericals correctly. Because in numericals, you are going to get values. And that values will be in terms of distance. So if you exactly know where the image is expected, you can verify that the answer that you got is correct or not. Okay, so remember these positions. So next object position between C and F. Object between C and F. Keep the object little closer to F. Okay. So one ray parallel after reflection go through F. Come. So and the other ray will be along C. ठीक है इसको हम क्या करेंगे So this is going along C. So it will come back and it will meet somewhere. ठीक है चलो. So this is AB, A dash, C and F. So tell me, what is the image position now?
Beyond C.
Beyond C. So image beyond C. Okay. What is the nature?
Real and bodies.
What about the image size?
Bigger and long.
So it is magnified. It's magnified. Sometimes it is also referred to as enlarged. Okay, it is also called as enlarged. Next, object position at F. Six. So this case is opposite of first case. First case, where was the object? Infinity. And where did you obtain the image? At F. Now when the object is at F, where do you expect the image? At F. Okay. So very simple. So there. So one we are taking parallel and next we will take along C. It will be reflected back. Okay, so this will go to infinity. Okay, so image. So parallel rays are supposed to meet at infinity. So in this case, we would say image at infinity. Will it be real and inverted? Yes.
Yeah.
Whenever the image is forming in front, all the images that are forming in front will be real. This is a front end. So real and inverted. Images that form behind the mirror, only those images are virtual. What about size?
Magnified.
Only
highly magnified.
highly magnified. That was highly diminished because when it goes to infinity, how big is the object from the principal axis? You don't know. Indeterminate, right? So we would say highly magnified. So till sixth position or fifth position, if you count 1 and 2 as 1, the image size is going bigger, bigger, bigger like that. And it is going away from the mirror. The object is coming closer to the mirror. And the image is going away. And the size increasing. Okay? Till here it is okay. So these rays are parallel, right? Now the next case and the last case. Where is the object?
Between infinity.
Yes. So object between F and E.
Sorry.
No control over leg. So now you will see that the image will form behind there. So in all diagram, one ray we have taken parallel, which after reflection has gone through focus. Okay. And the other will take along C. So now you can see that the ray is diverging after reflection. So when you stretch it behind, hello, yes, कौन सुप्रिया मैडम है क्या? ये उदय बोल रहा हूँ अभी, इनको मेरे को लगा विजय कल फोन किया था मैंने. No worries, no worries. Okay, so you have when the object is placed between F and P. So this is A, B. You have A dash, B dash. So for the first time, you are getting the image behind the mirror. So when it is behind the mirror, it has to be virtual and direct. So where is the image? Image behind mirror. Image behind mirror. Virtual and upright. Virtual and upright और उसी को हम direct view. ठीक है? What about the size?
Magnified.
Magnified or highly magnified?
Magnified.
Magnified only. Why not highly magnified? Because the image is comparable to the object size. The size of the image is comparable to the object size. Is that clear? So now look at all the distances. In this case, I'll now mention the distances. So this is your focal length. Where the distances are measured from? From P. this is my object, and this is the image distance. So what is u? Object distance. Okay. So this is PB. Then you have F is focal length. Then V is image distance. So these are important. All the distances are measured from pole, EV dash. So just keep these distances in mind. And you also have, this is AV is object height and this is image height. So what is O? Object height, which is BA, right? So distances are measured from either principal axis above or pole. So pole नीचे है, pole से ऊपर. And what is image distance? Image height? Height is HEI or HIE?
HIE.
HI.
HIE.
HEI. Or
See, for the first time out, I got a spelling correct.
height.
Make sure, is it HEI or
It's
HIE?
correct. It's correct.
HEIG.
I can mug up few things. B dash.
HIE.
देखो, I have mentioned all this because now we are going to study next is sign convention. So all these has different signs according to sign convention. So keep these distances in mind, how they are measured. So they are measured from P to the respective points and from principal axis either above or below. So everything to the left of P is negative, everything to the right of P is positive, everything above P or above principal axis is positive, everything below principal axis is negative. That's it. This is the sign convention. Clear? Same as your Cartesian sign convention. So P becomes origin, XY axis में जो graph होता है. Always P becomes origin and distances are measured from P only. P से left में negative, P से right में positive, P से ऊपर positive.
नेगेटिव है.
इसमें सब नेगेटिव, इस केस में सब नेगेटिव है. कॉनकेव में सारे नेगेटिव आ गए यहाँ पे, खाली यहाँ पे जो B है वो कहाँ पे आ गया? B पॉजिटिव हो गया. Only for this case you will get B positive. बाकी सब केसेस में F क्या है? नेगेटिव. ठीक है. और ये क्या हो गया? U. U तो हमेशा नेगेटिव हो. समझ आ गया? ऑब्जेक्ट हमेशा पॉजिटिव होगा क्योंकि ऊपर है और यहाँ पे इमेज भी पॉजिटिव है. खाली यही एक एक्सेप्शनल केस है, बाकी सब में तुम्हारा इमेज कहाँ पे है? नीचे है, ऑब्जेक्ट पॉजिटिव. यही साइन कन्वेंशन है. और अगर तुमने साइन ठीक से नहीं लिखा तो तुम्हारा न्यूमेरिकल का आंसर कभी जिंदगी में सही नहीं आएगा, भले तुम्हारा कैलकुलेशन ठीक हो. ठीक है. न्यूमेरिकल में कभी भी जो डेटा वैल्यूज है, only values are given, but you have to use sign convention to take the data with appropriate sign. ठीक है. हमने अभी कॉनकेव मिरर कंप्लीट कर लिया. कोई क्वेश्चन? If you have any question in image formation by concave mirrors, you can ask. Just go through all the object positions and the nature of image uptake. Everything I have written in red, very important from sign convention point of view. you see the focal length for concave mirror is on the left side. So for concave mirror, focal length will be always negative. So all the diagram from till here. वर्चुअल वाला करो एक ही हमारा बचा है इमेज फॉर्मेशन बाय कॉन्वेक्स मिरर सो इसमें दो ही ऑब्जेक्ट पोजीशन है ऑब्जेक्ट एट इंफिनिटी when the object is at infinity ठीक है तो ये नॉर्मल है when the object is at infinity it will be reflected away from focus ठीक है ये हो गया and the second ray also you take it from below the principal axis ये भी तुम्हारा कहाँ जाएगा away from ठीक है अब नॉर्मल बनाने की जरूरत नहीं है you know that if the rays are parallel then it will go either towards focus or away from focus tell me what is the nature of image image at FE होगा इस केस में भी but it will be virtual and direct so image at F behind the mirror आ गया है ऐसे देखो image at F behind the mirror ये जो डिस्टेंसेस मैंने रेड में लिखा है ना ये तुमको सिर्फ समझाने के लिए लिखा है रे डायग्राम में तुमको डिस्टेंसेस मेंशन नहीं करना है फॉर इमेज फॉर्मेशन डिस्टेंसेस का यूज अभी आगे आएगा लेकिन मैंने अभी समझा दिया तो सो दैट यू आर क्लियर हो ठीक है जब सिर्फ रे डायग्राम बनाना है तो डिस्टेंसेस मत मेंशन करो व्हाट इज द साइज eyelid image फोकस पे जब भी इमेज बनेगी तो कैसी बनेगी पॉइंट साइज या eyelid image अब जब भी तुम कॉन्वेक्स मिरर यूज कर रहे हो उसका फोकल लेंथ किधर आ रहा है अभी? फोकल लेंथ इधर है, ठीक है, और इमेज भी किधर है? इमेज और एफ सेम है, और तुम्हारा ऑब्जेक्ट किधर है? ये साइड, ऑब्जेक्ट लेफ्ट साइड है। वी डोंट नो हमारा u किधर है? इंफिनिटी, लेफ्ट साइड। तो u is always negative for any mirror. f is negative for concave, positive for convex, and v will depend on the nature of image. अगर मिरर भले कॉन्केव है, वर्चुअल बना है तो कॉन्केव में भी v पॉजिटिव आएगा, रियल बना है तो नेगेटिव आएगा, ठीक है। अब सेकंड रे डायग्राम क्या है? What is the second object position is in this case?
Infinity and
Yes, object between infinity and pole. और कुछ पॉसिबल ही नहीं, ठीक है। ये वाला क्या था? यहाँ पे ऑब्जेक्ट हमारा इंफिनिटी पे था, तो इमेज एट एफ बिहाइंड द मिरर, यानी वर्चुअल बनेगा बिहाइंड द मिरर, यहाँ ये बिहाइंड, ये फ्रंट, बिहाइंड पे बनने वाला इमेज हमेशा कैसा बनेगा? वर्चुअल, ठीक है। तो ये हमारा फिर से कॉन्वेक्स मिरर लिया हमने, दो पॉइंट्स मार्क कर दिए, ठीक है। अब हमारा ऑब्जेक्ट इंफिनिटी और पोल के बीच में नहीं है, लेट अस से इट इज हियर, ये हो गया हमारा एक, so one ray parallel, it will go away from focus, दोस्तों ऐसे हो गया। दूसरा रे हम ले रहे हैं सी की तरफ, दूसरा हम सी की तरफ ले रहे हैं, ये हो गया सी, ये हो गया, ठीक है। तो सी की तरफ जो जाएगा वो सी से ही वापस आएगा। No direction has to be shown behind the mirror. Mind you, ray will not cross the mirror because it is reflected. This is the reflecting side. So all the direction, incident and reflected, has to be on the front side. Everywhere, every case. Direction will not be marked behind the mirror. So where are these reflected rays appearing to diverge from? From this point. So this is the point.
between and
Yes. So this is A dash, B dash. Okay, so image between P and F behind mirror. ठीक है, second nature
virtual and
and size diminished. So the virtual image formed by convex mirror are different than the virtual image formed in concave mirror. What's the difference?
concave and magnified.
Yes, the virtual image in concave mirror is magnified. That's why the dentists use concave mirror. They put that mirror inside your mouth and see the magnified image of your tooth. Okay? To take any decision. they insert spoon-sized mirror inside your mouth to check the status. Have you seen dentist's mirror?
Yeah.
This is how they use it. This kind of a mirror they insert inside your mouth and then they take the. ठीक है, उसको बड़ा हो जाएगा. Sometimes the shaving mirror is also concave. So you see, so you stand close. You have to stand between F and P. So mirror का जो focal length है वो बड़ा होना चाहिए concave mirror, so that when you are standing at a comfortable distance, your face looks bigger. Okay, so that's concave mirror use. But in the rear view mirror of your vehicles, all the mirrors are convex. That's how all the size, whatever big size the vehicle could be, the full vehicle will be visible to you, and it is upright, so you are not confused. If you use concave, it will be upside down. तुम concave mirror यहाँ पे use नहीं कर सकते because objects are far away, and for far away object in concave, the image will be real and inverted. That's why they are not advised to be used in vehicles. Whereas यहाँ पे distance does not matter. Whatever is the distance, the image is always virtual and direct or upright. So you won't be confused. Is that clear? So this is it. So what have we observed? In concave mirror, all kinds of images are formed. Real, inverted, highly magnified, से लेके highly diminished, से लेके same size, and also virtual. So all different varieties of images are possible in case of concave mirror. Whereas in convex mirror, only one type of image is formed, virtual and direct. No real and inverted. And size is also less in case of convex mirror. It is never equal or magnified or highly magnified. So only one type of image is formed here. Virtual, erect, and either diminished or highly diminished. Is that clear?
Yeah.
So with this knowledge, now you are equipped to solve numericals. ठीक है? So first we'll discuss the sign convention, which I have already discussed. So देखो sign convention. So origin is whole. What is the first thing? Origin is whole. All distances to be measured from pole. All distance. So there are two types of distances you are measuring. So you are measuring it on x-axis and you are measuring it on y-axis. Maths में जो तुम्हारा x-axis है वो क्या है यहाँ पे principal axis. So principal axis क्या है तुम्हारा? वो लिखा होगा, ठीक है? Principal axis is x-axis. It is same as Cartesian that you use in graphs, math graphs. खाली जो origin है उसको पोल कर दिया, x-axis को principal axis बना दिया, ठीक है? So distances that are measured on x-axis are what? Which distances we will measure here? F, U, and V. Only these distances will measure here. So on x-axis पे तुम क्या measure करोगे? क्या करोगे? Focal length, object distance and V. ठीक है? और y-axis पे क्या measure करोगे? Size of object and size of image. वो y-axis पे measure होता है. एंड हाउ यू विल पुट साइन, P से लेफ्ट में नेगेटिव, P से राइट में पॉजिटिव, और P से ऊपर या प्रिंसिपल एक्सिस से ऊपर विल बी पॉजिटिव ऑन बोथ साइड्स, और नीचे होगा तो नेगेटिव। इतना ही है। Any distance which is left of P is negative, any distance which is right of P is positive. Anything above principal axis or above P is positive, anything below is negative. यही तो है तुम्हारा कार्टेशियन साइन। It is the same. ठीक है? अब न्यूमेरिकल में जो भी वैल्यूज गिवन है, तो फर्स्ट एंड फॉरमोस्ट यू हैव टू फिगर आउट व्हाट इज द नेम ऑफ द मिरर। जैसे ही नेम ऑफ द मिरर पता चल जाएगा, हमको ये मालूम पड़ जाएगा whether its focal length will be positive or negative. मालूम पड़ा कॉनकेव मिरर है, फोकल लेंथ क्या होगा? नेगेटिव। कॉनकेव में फोकल लेंथ क्या होगा? कॉनकेव का फोकल लेंथ इधर आता है, कॉन्वेक्स का फोकल लेंथ किधर आता है? इधर, क्योंकि फोकल लेंथ इज डिस्टेंस pf, रेडियस ऑफ कर्वेचर इज डिस्टेंस pc। तो कॉन्वेक्स मिरर के लिए रेडियस ऑफ कर्वेचर और फोकल लेंथ पॉजिटिव हो। u हमेशा हम p के लेफ्ट में रखते हैं, x एक्सिस। कौन से डिस्टेंस x एक्सिस पे है? ऑब्जेक्ट डिस्टेंस, इमेज डिस्टेंस, फोकल लेंथ। तो ये इधर p के लेफ्ट में आता है u, so u is always negative, always। कोई न्यूमेरिकल दिया है, कैलकुलेट करने के बाद तुम्हारा u पॉजिटिव आ रहा है, मतलब तुम्हारा कैलकुलेशन गलत है। समझ आया? सॉल्व करने के बाद अगर u नेगेटिव आ रहा है, तुम्हारा कैलकुलेशन गलत है, क्योंकि u नेगेटिव ही आना चाहिए। कोई भी मिरर, अभी क्वेश्चन में दे दिया वर्चुअल इमेज है, ठीक है? तो वर्चुअल इमेज है तो आई क्या होना चाहिए? पॉजिटिव। रियल इमेज दिया हुआ है क्वेश्चन में, तो आई क्या होना चाहिए? नेगेटिव। व्हाट इज आई? इमेज साइज, हाइट ऑफ इमेज और साइज ऑफ इमेज। ठीक है? क्योंकि वाई एक्सिस पे, इसलिए हम उसको हाइट बोल रहे हैं। वर्टिकल है ना, हॉरिजॉन्टल नहीं, वर्टिकल। ओके, बस। सो ऑब्जेक्ट साइज image size 4 and 5 to be measured on y-axis. That's it. तो y पे हमको पता है, ऊपर वाला पॉजिटिव, नीचे वाला नेगेटिव, ठीक है? तो अब हमको ये साइन कन्वेंशन कहाँ पे यूज करना है? साइन कन्वेंशन कहाँ पे यूज करेंगे? अच्छा, इंसिडेंट रे डायरेक्शन इज ऑलवेज नॉट लेफ्ट टू राइट। इंसिडेंट रे, इंसिडेंट रे इज लेफ्ट टू राइट। किसी क्वेश्चन में उल्टा कर देते डायरेक्ट, तो वहां पे साइन कन्वेंशन क्या हो जाता है? All the distances in the direction of incident ray will be positive. तो ये साइड पॉजिटिव ही आएगी, देखो। All the distances measured against incident ray will be negative. समझ आया? Note. All distances. Distance अभी भी P से ही measure करना। All distances to be measured from P. In any case. Along incident ray are positive, else negative. ठीक है? कभी कभी पूरा डायग्राम पलट देता है क्वेश्चन पूछते टाइम, तब ये वाला फॉलो करना, खाली एक्स एक्सिस में एप्लीकेबल, वाई तो वैसे ही हो। ठीक है? along incident ray are positive। समझिए, उल्टा हो, ये सेम ही है एक्चुअली। अब ये साइन कन्वेंशन यूज कहाँ करना है? मिरर फॉर्मूला में और मैग्निफिकेशन फॉर्मूला, ठीक है। Is used in mirror formula. मिरर फॉर्मूला है 1 by f is equal to 1 by v plus 1 by u, और दूसरा फॉर्मूला है लीनियर मैग्निफिकेशन फॉर्मूला। ये क्या है? m is equal to image size upon object size, और m is equal to minus v by, ये दो फॉर्मूला। इस फॉर्मूला का डेरिवेशन नहीं है तुमको, सिर्फ ये फॉर्मूला में, ठीक है। So we tips for solving numericals. अननोन डेटा के लिए साइन कन्वेंशन नहीं लगा, समझ आया? You have to take all given data with appropriate sign as per sign convention. लेकिन जो अननोन है, जैसे तुमको f कैलकुलेट करना है, अगर मिरर दिया है कॉनकेव तो तुम यहाँ पे माइनस f नहीं लिखोगे अननोन डेटा, खाली जो गिवन डेटा है उसी में साइन कन्वेंशन यूज करना, ठीक है। अननोन का साइन कैलकुलेशन के बाद आएगा। Okay, sign for unknown data to be obtained after calculation. So this is clear? Okay. So now let's solve. Do we have time for solving numericals?
No.
Okay, so we stop here. Okay, and we'll wait for the bell to ring. In the meantime, you'll just browse through what we have done today. See the hard-working boys, or hardly working boys, lost control over their bodies. Come on, boys, buck up. 3 more hours to go.
No, not for them.
Not today.
No. For them, yes.
They have to attend 3 more hours, right?
Yeah.
Jolly man.
No.
Jolly man, na? Okay. So what is she going to teach today? History or geography?
Geography.
That's fun, na? Geography is fun. No? Geography is not fun. Physics is not fun. Geography is not fun. So then what's fun?
Chemistry.
So you are a chemistry person. What about your
Biosphere.
You are staying there for next lecture? Nobody?
No.
Lucky. Okay, so I'll see you tomorrow. I think the marathon lecture will be stopped tomorrow.
Yeah.
And we'll be done with this chapter. So big chapter. Maybe we'll start sound.
Sound, yeah, that's the
Definition of sound wave.
Huh?
Sound wave.
Sound waves. And then two more chapters. Magnetism and
Sound wave.
only two more. Remaining. Acha. Arey wow. Let me start with magnetism. Very small chapter. We'll do that. No? You want me to start with sound?
Yeah, I don't like it.
Oh, it's very simple.
It's very simple.
After we finish magnetism, we'll start liking. Chalo. Okay.
Bye. All the best. I want to bunk this class.
Just feel
Okay
like
then. Sign कर दिया ना भाग जाओ.
This time was acting so crazy after Seven Uncle's BMW, right?
after it,
Seven Uncle's BMW. Guess what? Name for every company. You see, you didn't know anything about them.
we
Okay.